Section 3.1, our goal is to identify line relationships. We're going to start with coplanar lines. Coplanar lines are lines that are in the same plane, and since they're in the same plane, they are either parallel or they're intersecting and they cross in one point. Parallel lines are coplanar, and that's important. We need to know that our parallel lines are coplanar. They're on the same plane. If you draw them on your page, it's the plane that is your book page or your notebook page. These are coplanar lines that do not intersect. They run the same direction, and they're what we call equidistant. They're the same distance apart all the way through. So this first line is line A, and when we name a line, this should be a script letter. It kind of looks like a cursive letter. And the second one is B, and the symbol here reads A is parallel to B. The symbol for parallel looks like parallel lines. Skew lines are non-coplanar lines. So we need to know that skew lines are non-coplanar. These are not in the same plane. These are two different planes. They're never parallel and they never touch. So they're two lines going on different levels that go in different directions. And I'll show you on a picture. We're going to use the box like we did with planes to show you where these lines are. So we'll show you some skew lines. Parallel segments and rays. If a segment array lies on a parallel lines, then the segments and the rays are parallel. So if it's part of parallel lines, then any segments or rays lying on those are also parallel. Okay, so we're going to use the edges of the box. So things like segment AD, segment DC or CD, segment CB or BC, segment AB, DG, which is dotted because we cannot see it, it's kind of in the back of the box, segment EG, GH, CH, FH, BF, EF, and AE. So those are all of our segments we're using. We're going to use those edges of the box to represent lines. So name two parallel lines. I'm going to pick line AB, this one, and then I'm going to pick something parallel to that. So AB is parallel. I could use EF at the bottom of the box, DC in the back, GH, the back bottom of the box, that edge, anything that's not going to intersect but is on the same plane. So if I used EF, that's the plane that's the front of the box. If you use CD, that's the plane that's the top of the box. GH and AB form that plane that's diagonal. That's kind of an imaginary one that you have to picture in your mind for the box. So we'll just use EF. And those are two parallel lines. Number 2 says name two skew lines. Skew lines are on different levels going in different directions. So I'm going to start again with line AB. Line AB. Now, skew lines are non-coplanar, so I'm not going to pick anything else that's on the front of the box in that plane, or on the top of the box in that plane, or like GH that would be with that diagonal one. It needs to be on a different plane, separated away from this line, and going in a different direction. And the different direction is important, so I'm going to pick CH. These lines are not parallel, but they're never going to cross because this front one is spaced apart from the back one. They're never actually going to intersect. One's in the front and one's in the back. And we'll look at skew lines with the box in class so you can get a better idea that these are spaced apart. One on the front of the box going backwards and forwards, and one on the back of the box that goes up or down. So they're running different directions, but they don't cross because they're, however wide the box is, they're that far apart. Name two intersecting lines. We'll start again with AB. And I need any line that's going to cross or intersect AB. So I'm going to use AD. You could have used AE and AB. You could have used AB with BF or AB with CB. All of those would intersect. Name two coplanar lines. Remember, co means together or the same. So these are on the same plane. Our planes are the faces of our box, so the front of the box is a plane. So I could use AB and EF. Those are both on the front of the box. Also remember that parallel lines are coplanar. So if you pick parallel lines, then you're naming coplanar lines. Two non-coplanar lines not on the same plane, be really careful. Go with skew lines. Go with lines that go different directions, because if you pick something like AE and then you're trying to space it apart and you pick CH, there is an imaginary diagonal plane that runs through those two. So I cannot use those. We want to pick skew lines. So I'm going to pick one that's spaced apart but goes the opposite direction. So GH. So I'm going to use AE, and these are lines. They need the arrows on the end. And GH. Those are spaced apart. They're never going to cross, but they're not parallel. Parallel planes are two planes that do not intersect. For example, the top of the box and the bottom of the box are parallel planes. The left and right sides of the box are parallel planes, and the front and back of the box are parallel planes. We have two postulates that we're going to write down. Once we write the first one, then we'll draw a picture, and then we'll talk about the second one. Postulate 13, and you do not need to know the postulate numbers. That's just the order they appear in your book. This is called the parallel postulate. If there is a line and a point not on the line, so PT is point, then there's exactly one line through the point parallel to the given line. Please pause and write down this postulate before we draw the picture. So this postulate says, if there is a line, here's my line, and you would be given this line, and a point not on the line. What the question would ask is, how many lines can you draw through the point that would be exactly parallel to the given line? So I'm going to start, and I'm going to draw one line through the point exactly parallel to the first line. They're equidistant. If I try to draw a second one, it's not going to happen. It's going to be right on top of the first line. So if you're given a line and a point not on the line, there is only one line that you can draw through the point that's parallel to the first one. And we do have a symbol for parallel. When things are parallel, you put these little arrows on them that says that those lines are parallel. Postulate number 14 is called the perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. Please pause and write this down before we go to the picture. So this one talks about perpendicular, but it starts the same way. If there is a line and a point not on the line, and this one would ask, how many lines can I draw through the point that are perpendicular? Remember, perpendicular to, there's our symbol. They meet at a right angle. So it needs to be perpendicular to the line we started with. So I'm going to draw my first one at exactly 90 degrees. If I try to draw another one to be exactly at 90, it has to be drawn on top of the first line. So there is only one line through this point not on the line we started with that's perpendicular to it. Other kinds of lines, and these are the lines we're going to focus on most in Chapter 3. This line is called a transversal. A transversal is a line that intersects or crosses two or more coplanar lines in different points. So this is saying I'm starting with two coplanar lines. These are on the same plane. They're on the plane that is your computer screen. So there's my two lines. The transversal is this one that intersects both, and it has to cross them in different points. So I just put X's on where it intersects. They can't all cross in one point. So this one is called a transversal. It crosses two lines at different points. We're going to do some things with this. Kind of looks like a number sign or a pound sign picture. I could say these are my two lines. this top one is a transversal or the bottom one. Or I could say the black lines are my two lines and I have a transversal on the left in red and a transversal on the right in red. We have specific angles that are formed by transversals, and you're going to need to know these angle names. We will use these throughout the chapter, and we will use these to write a couple of proofs for parallel and perpendicular lines. The first thing you need to know is which are the lines and which one's the transversal. So I'm going to put the lines in red. Here's my two coplanar lines. And this one is the transversal, the one I did not color in that's crossing those two. This is important because we're going to talk about interior and exterior. When we talk about interior, we mean between the two lines. Exterior is outside of the two lines. If you have trouble with those words, think of interior design or interior decorating. People who work inside the house, exterior is the outside. So if I'm looking for interior angles, that's everything between my two lines, everything between the red lines. So interior angles would be angle 2, angle 3, angle 6, and angle 7. Those are the ones between the two coplanar lines. Okay, again, these are my two lines still. All of these are going to use the same picture, so you could draw the picture once and then make a list. Interior angles were 2, 3, 6, and 7. Exterior angles outside of the two lines are going to be angle 1, angle 8, angle 4, and angle 5. Exterior is outside. One thing you want to be careful with is while we're using the same picture for these examples, the order that these are numbered in will change as we work through different problems. So don't just memorize the numbers, actually look at where those are and what angles we're discussing. The first specific kind we're going to talk about are called alternate interior angles. So interior, we're going to be between our two coplanar lines, and I'm going to outline those in red again. Here's our two coplanar lines. I want to be inside of those, so in the interior. Alternate means they're on opposite sides of the transversal. So if I used angle 2, and I want one that's non-adjacent interior angle on the opposite side of the transversal. So I don't want something right next to 2, although it needs to be inside, and it needs to be on the opposite side of the transversal. So I'm not going to use 7 because it's adjacent. It's right next to 2. We want to use 6. You kind of go diagonally. So angle 2 and angle 6. You could also do angle 3 and angle 7. Interior, in between the two lines, alternate means they're on different sides of the transversal. We also have alternate exterior angles. So this time we want to be outside of our coplanar lines. Here's our lines. This one is our transversal. I'll just label it T. We want to be outside, so I'm going to start with 1. And you want to be on the other side of the transversal, but not right next to it. So we're going to go all the way to the other side and use 5. So angle 1 and angle 5, angle 4 and angle 8. Those are alternate exterior angles. Corresponding angles are angles that are in matching positions, one on each line. And when we talk about matching positions, we mean the position where it is on the line and the position where it is compared to where your transversal is. For example, if I pick angle 1 is above the line it's next to and to the left of the transversal. Kind of in this group, it's top left. When I go to the other line, I want something above the line, left of the transversal. So angle 1 and angle 3. In each group, those are the top left. Angle 8 would match up with angle 6. They're both to the right of the transversal and above their line. Angle 7 would match up with angle 5. Those are to the right of the transversal and below their line. And then angle 2 and angle 4. Those are to the left of the transversal and below their line. Make sure you write down these definitions. You need to know these names. Alternate interior, alternate exterior, corresponding. The last kind are called same side interior. In your textbook, you will see these called consecutive interior. And what we're going to do so that you get both names is the textbook will call them consecutive interior. When we're working through handouts in class on any of the worksheets, we'll call them same side interior. So you really understand that those words are interchangeable and you get comfortable with both names. Same side interior are interior angles on the same side of the transversal. So here's my two coplanar lines in red. The transversal is the one that crosses both at different points. I want two angles that are in between the lines. They're interior, but they're on the same side of the transversal. So angle 6 and angle 7, angle 2 and angle 3. 6 and 7 are same side or consecutive interior angles. 2 and 3 are same side or consecutive interior angles. So our examples, we're going to go through and have you practice naming these angles. And we're going to save these answers for class for our discussion. So I want you to work through. There are 4. You need all 4 examples in your notes. Number 1, name a pair of corresponding angles. And you can always go back and look at where correspondings were. Corresponding are in the same position. So using this picture, and this one picture will be used for all 4 examples, with it numbered like this, make sure your numbers are in the same spot. Name a pair of corresponding angles. Number 2, name a pair of alternate exterior angles. Make sure these are your lines, inside, outside. This one is your transversal because it's the one that intersects the other 2. Alternate exterior angles, opposite sides of the transversal, outside the 2 lines. Number 3, name a pair of same side interior angles. Same side of the transversal in between the 2 lines. Number 4, name a pair of alternate interior angles. Opposite sides of the transversal in between the 2 lines. We will discuss those 4 answers when you come into class, and the homework we'll be working on tomorrow is on page 132 to 134, 10 through 19, 21 to 26, and 48 to 62, and that is all problems.